Welcome back to Lecture 4. This is Jason Baker, and our next topic is Simple Storage Service, or AWS S3. AWS S3 is an object-based storage service where you can store data in a very secure, durable, and highly scalable manner. Now, when I say that it's an object storage service, the first question you might have is, well, what do I mean by an object? Well, basically, an object is essentially a key and a value plus some metadata, where the key is the name of the file that you're storing in S3, and the value of that file is the actual data. And then S3 objects have metadata associated with them, and the metadata might include information like the name of a person and the account which uploaded the file into S3, the date and time it was uploaded, the version ID of the file, and other descriptive information. S3 objects are web accessible storage, meaning that every object in S3 is also accessible via a web URL. And we'll see some examples of that here in a little bit. Now, S3 data is a service which is a regional service. So when you are creating your S3 objects and loading them into S3, you're doing so in a particular region. The objects and the data that you store in S3 is stored across multiple availability zones within the region. So the data is essentially replicated across multiple storage systems in within a region. And this provides 11 nines of durability. In other words, 99.999999999. I'm not sure if I said enough nines there, but basically 11 nines. So extremely high durability. What does that mean? Well, durability means basically represents the risk associated, the risk of basically losing the data once it's been stored in S3. 11 nines durability means that it's possible that if you uploaded a billion files into S3, then one of those files might be lost or corrupted. And so 11 nines availability durability is extremely high. In terms of availability, your ability to access your data that's stored in S3, the S3 service provides 4 nines availability, meaning that your data is accessible within S3 99.99% of the time. You can store an unlimited amount of data in S3, and the individual files, the individual objects that you store in S3 can be anywhere from 0 bytes all the way up to 5 terabytes in size. The most important thing to remember about S3 is that S3 is an object-based storage system. You're uploading files into S3. S3 is not itself a file system. You can't install something like a database or an operating system on S3. We're only storing files. Now, S3 storage is partitioned into multiple namespaces that are called buckets. And when you upload a file, you're uploading a file into a bucket. You could think of a bucket as being like almost like a folder in a sense, although you can create folders within buckets. They're not real folders. And remember, this isn't a file system. Folders are just a way to partition buckets into multiple segments, multiple namespaces, essentially. It's really important to note that when you create a bucket in S3, the bucket name is global and must be unique, meaning that when you create the bucket name, you are the only person in the world that can be using that particular bucket with that particular name. It has to be globally unique. And that's because all the objects in S3 buckets are web accessible, and the website URL has to be globally unique in order to point to your particular storage namespace and the objects in it. Initially, you're limited to creating 100 buckets in your account, but like most of the other limits that are initially set in your account, you can increase the number of buckets if you need more. You can make a request to AWS support, and they will evaluate that request and increase that limit for you. When you upload data into an S3 bucket, the S3 follows two different consistency models based upon the type of action that's taken place. If you recall back to my discussion of the CAP principle, where consistency was one of the defining characteristics in the CAP principle, there are two different types of consistency: write consistency and eventual consistency. When you upload new objects into an S3 bucket, S3 uses read after write consistency, meaning that when you upload the object in S3, you can immediately read that object and read the data in that object, and it will immediately be available and consistent. On the other hand, when you update an object or when you delete an object, S3 uses an eventual consistency model, meaning that it's possible that in your application writes an update to an object in S3, and then your application immediately tries to read the data from that object. It's possible your application will read the old version of the data or read the old version of the object and not the new one. It might take a second or two for that object to be updated consistently across all availability zones within that region. And until that object is updated across all the availability zones, it's possible for your application to read a stale or old version of that file. Even if you delete it, if you delete it and your application tries to read it again, it's possible that if it does it very quickly, it's possible that it will still be able to read that object. So the moral of the story is that if you're working with S3 storage in your application, programmatically writing objects and reading objects, you have to be aware of this eventual consistency model to ensure that your application works properly. We can set up a number of different security access controls and policies on entities within the S3 service. You can set up security at a bucket level. You can set up security at a file or an object-based level. You can enable encryption at rest for increased security. S3 uses AES 256 encryption protocol. The encryption at rest means that once your data is stored in S3, that data is then encrypted, and it's encrypted meaning that'll actually prevent AWS staff from reading the data that's stored within S3. When you transmit data to and from S3, that data is transmitted using SSL TLS protocol, so the data is encrypted while it's being transported from your system or from your server into S3. And then you can also set up logging to track all of the access to your S3 buckets and the objects within those buckets for auditing purposes. From a cost standpoint, there are basically different there are three different sort of characteristics of S3 from a cost standpoint. When you upload data into S3, you pay for the amount of storage space that you are utilizing on a per gigabyte basis per month. And the cost, it goes down every year. I think right now it's somewhere around 10 cents per gigabyte. It could even be less than that now. So you pay for the amount of storage space you're using. You also pay for network bandwidth for any files that you retrieve from S3. Pushing files or uploading files into S3 won't cost you anything from a bandwidth standpoint. But if you download those files from S3, you may have to pay network charges depending on where you download those files from. If you are downloading those files from a server that is running in EC2, then you don't need to pay any bandwidth because essentially the data is being transmitted from one AWS service to another AWS service. As long as it's within the same region, there's no bandwidth charge. But if you decide that you're going to download these files from your office or from your home, then you're going to pay an additional bandwidth charge, and it's a pretty not small nominal amount. But if you have massive files that you're downloading, these charges can add up over time. And then finally, you also pay for the number of file requests when you make a get or a put request. When you retrieve files or if you update files, push new files into S3, you'll pay for a small fee per million requests. And you might be thinking to yourself, well, I'm never going to make a million requests to S3. But if you create an application, the application is servicing thousands, hundreds of thousands, millions of users, and it's storing data on S3, then your application could be generating tens of millions, hundreds of millions of requests. And again, those fees can add up over time as well. A couple different S3 additional S3 features I'll mention. There are different tiered storage options within S3 that we'll take a look at here in a bit. You can set up lifecycle management to automatically delete and archive data in S3 buckets. A common example is that you might want to set up a policy which automatically archives any data in an S3 bucket that is older than 90 days. That data then is copied and moved to a different tier of service, which is much, much cheaper. And then finally, you can enable versioning on a bucket, and that allows you to track changes to files, which can be really helpful at times. You might want the ability to roll back to a previous version of a file, or you might need the ability to audit changes to files over time. And versioning allows you to do that. I mentioned that you can set up different storage tiers within S3. The standard S3 storage tier is handles most general requirements. And again, that's the storage tier that provides 11 nines of durability and 4 nines of availability that I mentioned earlier. There are times where the default storage tier might not make sense for your application. And there are a couple other tiers that are worth looking at. The first one is what we call S3 IA, which is S3 infrequently accessed storage. And this is for data which isn't accessed all that frequently. But when the data is accessed, it must be available to the application immediately. This is a slightly cheaper storage tier than the standard one. In this case, again, you get the 11 nines of durability, but the availability is lower. Instead of 4 nines of availability, there's 3 nines of availability. If if you want to store non-critical data that you can easily reproduce, if it's ever lost, then you can utilize the reduced redundancy storage tier, the RRS tier. And in this tier of storage, the availability is high, 99.9949's availability, just like the standard tier, but the durability of the data is substantially lower. Instead of 11 nines of durability, you only have 4 nines of durability, meaning that 1 out of every 1,000 files that you store in RRS might just disappear, might be corrupted. And you're probably asking yourself, well, why would I ever want to store data in a storage tier where the data might disappear? Well, first of all, this our RRS storage is very cheap. It's much cheaper than the standard tier of storage. And sometimes we're working with data that we can afford to lose. The canonical example is something like a thumbnail image. A customer might upload their picture and your application will generate a thumbnail image. Well, maybe your application, instead of storing that thumbnail image in the standard tier, would store it in the reduced redundancy storage tier, which is cheaper. And if the thumbnail image ever disappears, then your application still is storing the original image and can just regenerate the thumbnail image. So RRS is really for that data that is not critical and that you can afford to lose. And then finally, the last storage tier is really a special storage tier. This is an archiving tier called Glacier. And this is by far the cheapest place to store data in AWS. And it's designed basically for long-term data backup. The biggest issue with Glacier is that if you ever want to access your data, it can take up to 3 to 5 hours to restore that data. So you wouldn't store data that you need to access frequently or even infrequently in Glacier. This is truly long-term storage and for data archival purposes. Okay, let's jump into an S3 dashboard here and do some hands-on work. Feel free to follow along with me as I walk through some of these steps. I've already logged into AWS and I'm going to click on the S3 dashboard. And once I'm in the S3 dashboard, I'm going to go ahead and create a bucket. Remember, a bucket is a global namespace. This is where I'm going to store my data, store my objects. So I'm going to create a bucket name. And remember, this name has to be globally unique. So I'm going to just create a name here that I believe will be unique. It should be unique. And the region I'm creating this bucket in is the U.S. East North Virginia region, also known as U.S. East 1. I'm going to click on the next button. And at this point, I can set up some properties on the bucket. I can set up versioning. I can set up the logging that I mentioned. I can set up data encryption. Let's set up encryption for this bucket. We want to, in this case, we're going to encrypt all of our data using the AES 256 encryption protocol. And this happens in the background, so this is totally transparent to us. Any data that we upload and store in S3 will now be encrypted at rest. So we'll save that and we'll click next. And here we can set permissions for this bucket. Right now, as the user, as the owner of the bucket, I have read-write permissions. I basically can do everything I want to. I could give access to other AWS accounts and allow other AWS accounts to access this bucket. I could even make the bucket publicly accessible. You have to be very, very careful about that. It's generally not recommended. There's very few use cases where you'd want to make a bucket publicly readable. And there have been cases, and you may have seen newspaper articles where organizations inadvertently created an S3 bucket and made it publicly available, or set up an object in the bucket that was publicly available, and that bucket contained really sensitive information. Maybe it was information about customer orders or customer credit cards or social security numbers and so on. Be very, very wary about setting up public access on an S3 bucket. These permissions look fine. We're going to go ahead and click on next, and it gives us a summary of the settings for the bucket. Everything looks okay. So I'm going to go ahead and I'm going to create the bucket. Okay, so here's my new bucket. I'm going to click on the bucket, and the bucket is currently empty at this point. I'm going to go ahead and let's say I'm going to upload a file to the bucket. So I'm going to add a file, and I can click on, I'm going to click on maybe one of the lectures and upload that. So I'm going to maybe click on the week 4 lecture. I'm going to go ahead and add that, and then click next. Once again, I can set object level permissions. In this case, this object is only going to be accessible by me. I'm not going to grant public access to this object. Click on next. Here I can specify the storage class for the object. Remember, we have different storage tiers: the standard, the infrequently accessed tier, and the reduced redundancy storage tier. I'm going to just leave it in the standard tier for now. We can protect our data at rest. I've already set up a bucket level encryption, and we can add metadata. We can add tags. So we'll talk about tags later, but we can add some metadata information to our files. And again, this is showing us a summary of our object that we're going to upload. I'll go ahead and click on the upload button, and you can see that now my file has been uploaded into the S3 bucket. If I go ahead and select this file, there's what I wanted to show you when I look at some of the properties of the file. You'll see that it shows me things like the storage class, the encryption level, and some of the permissions on the file. You'll also see this link here. Remember what I said, that this is web addressable storage. Every object that you upload into S3 can be accessed via a website URL. If I were to copy this website URL, oops, let me go ahead and copy this link. And I'm going to try to access that link in another browser window. Now, when I try to access that link in my web browser, I get this access denied message. Why did I get an access denied message? I thought that I was the owner of the account. So why isn't S3 allowing me to access that file? Well, when I try to access this file via a web browser, I'm not authenticated in on this web session. I'm an anonymous user somewhere on the internet trying to access that file. I would need, in order to access this file via my web browser, I would need to pass in some account credentials to S3 when I make this request. So because I didn't pass in those credentials, I get the access denied message in my web browser. Okay, let's see some other things that we can do. I mentioned that you can set up things like lifecycle rules. You can set up lifecycle rules to manage the objects. You can use lifecycle rules to automatically expire objects. If I click on a lifecycle rule, then I can add a rule name. So we'll just call it like remove data, and click on next. Next, expiration. We want to clean up current version of objects, expiration, configure expiration on a current version, and expire current version of object after, like 60 days. Next, and save. So I've set up a quick lifecycle rule to expire objects in that bucket after 60 days. So automatically delete them. Now I might not want to do this for my typical bucket. This might be like if I'm using a bucket for some, like maybe I'm using it for some temporary like batch processing or analytics work or something, and I want to make sure that objects get cleaned up automatically in that bucket over time. That's one way I can use something like a life cycle policy. And there's all kinds of policies I can set up. I can set up policies to automatically transition data from one storage tier to another storage tier after a certain amount of time or based upon some sort of event. There are many different options that you can set within S3. I've already uploaded a new file to the console, so I showed you a demo how to do that here earlier in setting up encryption. A couple other services that I wanted to make mention of in this part of the lecture are is other services related to storing data. Well, one of those services is a service called CloudFront, and CloudFront is a global content distribution network, and it is a service which allows you to cache files that are stored in S3 and cache those files in over 50 different edge locations that are located throughout the world. Now, these edge locations are not necessarily the same as Amazon's uh, Amazon's data centers. Their physical data centers that are located within availability zones. These edge locations oftentimes are located at major internet service providers in different regions of the world. And the benefit of CloudFront is that you can take a set of files in S3 and cache those files in all kinds of different remote locations. Caching just simply means that you're basically copying those files to these to remote locations. You can then design your application or website so that when when visitors are accessing your website and they need to access those files located in S3, your visitors will automatically be redirected to the files that are closest to their geographic location. You can imagine like a customer in Asia who's trying to access, let's say, a website located in the US. Well, if they could access some of those website images or large content files from a data center in Asia, then their access to your website is going to be much faster, and the customer is going to be happier because they're going to experience better performance. So CloudFront is used to accelerate your application, accelerate your website because it can move files from your S3 bucket or copy files from your S3 bucket and cache those files in locations throughout the world. Here's a quick map showing all the different CloudFront edge locations. This map is a year or two old, so there's likely to be more edge locations available today, but you can see how they're spread all over the world. Another really interesting service that AWS offers is a storage transport service called Snowball. And Snowball addresses the question of how do you get large amounts of data into and out of S3? Let's say you had like a petabyte worth of data that is stored within your organization and you want to move this data into S3. Now you could try to copy that data over the internet, but it might literally take you weeks, maybe even months to copy that data over based depending upon your internet bandwidth. Well, sometimes it's just easier to copy that data to a hard drive or set of hard drives and ship it to somebody versus trying to move that data and push it over the internet. What Snowball is it's this hardened case that includes a set of hard drives, and it has a network and it has a USB port, and it's shipped to you by Amazon, and it uses an e-ink electronic label, a shipping label. You take this case, you plug it into your network, and now you can copy data from your storage systems onto into the Snowball container. Once your data has been copied into the Snowball container, the e-ink label automatically changes, and it has a return address. The FedEx or UPS then picks up the Snowball container. Your data is all completely encrypted when it's stored in this container, and the shipping service then sends it back to Amazon. Amazon can then load that data directly into S3 buckets for you. So Snowball is a really easy and interesting way to transport data and ship very, very large amounts of data to and from AWS. So if you ever want to get your data out of S3, you can also use Snowball to retrieve your data.